Hi, in this video I'm going to talk about the progress I've done to my panel, one of my existing panels, and my goal is to have the RGB LEDs. As you can see over here, it's a mix of, the RGB is red, green, blue, and so it's all, the red, green, and blue LED are built into the same LED, the three aspects. So what I did is I have these LEDs. These are the RGB LEDs. But what's neat about these ones is they also incorporate the WS2811 chip. So you don't need to have those 2811 chips, a board connected up that will send the signals to regular LEDs. In this case, it's RGB LEDs with the chip built in. There's a little bit of difference, the pin configuration, the way it is. So what happens is these four pins, one is the center, in the center is positive and ground, 5 volts, and then on the outside is the in and the out. So basically you daisy chain all the 5 volts and ground, and then the in from one, you have the signal coming in, and then from the out goes to the in on the next one, and that guy's out goes to the in on the next one, and basically you daisy chain them like that. So it reduces a lot of wiring, because you don't have like an input from each LED going to a board. They just daisy chain to each other. So these are the LEDs I purchased. They're like 5 millimeters, and they're a little bit flat top. It's a bit of a unique type of shape to them. So what I did is, since I had this is my existing board. Remember, I have this one uses just single red LEDs. And my other board was a single green LEDs, but I wanted everything together in the same board. And since I already purchased, these are the boards from JLC PCB, and I had 10 of them made. That was the minimum order. So what I did is I drilled out the little holes where these LEDs, because you can see the little circle there. It's for 2-pin LEDs. So what I did is I ended up drilling them out, and from behind I pushed in these little LEDs here. So we'll look at the back of the board there. So basically, yeah, what I'm doing is I'm connecting all the center pins. Like you can see I've been bending them over and stuff, because again, I'm not using the circuit board, in the same way as that. I'm just using it as a template. So, and then I've put some, it's rubber cement, a type of insulation there, just to make sure that the pins they're not touching each other. You can see they're all over the place here. So I'm insulating them so that, yeah, that's it, they don't touch each other. And so I wired them all up, a bunch of them. Now I'm not finished. You can see there's a bunch here that are not done, and here that's not done. And the way I'm testing them out now is, so the wire comes in here. This is a plus 5 volts ground and the signal, and that's on this cable, and it's going to this is the board that was designed by Hans Tanner and IoTT.org, his website. I'll put a link in the comments. And this board is using is connecting to a LocoNet device. So what happens is, as I anywhere on the layout where if I press some buttons here, I'll update that board. If I press the buttons on the side of the layout here, I have RGB push button LEDs, which are connected to, there the hardware I'm using is from Sweden, the mollehem.se website. I'm using their boards. And this one with the Hans Tanner's board there, I think it can operate 525 aspects. So that's 525 different LEDs, but you have to divide by 3 because each LED does the 3 colors. The other thing I temporarily put one of these boards here. This is from Mollehem. That's their board. It does 64 aspects. So the thing is, if I wanted actually to use this board instead of that board, well, that board right now I don't have the anything connected switches for the inputs. So if I press the button to trigger the roots, it's not connected to that board. That's another piece of hardware I would have to add. But I actually have some the yellow hat from his website on order, and that'll give me like 32 inputs. So I end up having 32 inputs, which I just need 29 here, and 525 LEDs. I only need technically I have like 30 LEDs, but I think I have to multiply it by 3. So I think all the LEDs, no, sorry, not 30 LEDs, 84. I think it's around 84 LEDs. Yeah, 84 times 3, because 84 LEDs, and each one does 3 colors. So his board should be able to handle that. But the thing is, he was talking about some of the higher level logic that you have to, you know, sort of like configuration to say, well, if this light is on, and do this and that and this. So there's a little bit of functionality that's missing, but apparently it's going to be in the newer version. So I look forward to that. But in the meantime, I'm testing with this board, and I'll be have a few of these on order. Because since he only does 64 aspects, I need 84 times 3. I actually need 4 of these boards. So I'll be testing with those. So, you know, you have to think, do I use 4 of these boards, or when that one's going to be finished, or the next generation of his board I'll be working on? You know, it's just the only, like I said, the only missing link sort of is like the software is not up to speed to do all that extra stuff, but the hardware is there. So I'll be testing with both. So temporarily I put this little board to see how that would place, and I would need 4 of those boards. So anyway, moving back to this side, you see as I flip routes, let me take another route. See, not all the LEDs are on there, but because they're not all wired up, but most of them are. If I go to, let me see, I select the route down here. See, that route goes green. If I select the next route, that guy will come on green, and so forth. Take another route. That one. These ones. That's another route there. So a lot of routes are coming up, and there's also like block occupancy, which is in this case these tracks. I'm going to trigger these tracks. Block occupancy. You can see one of them is already red. If I take it out, remove the train, it goes out, red. Remove this train, add it, it goes to red, occupied, and off. So the thing is, I don't want it to go green when it's unoccupied. I only want to see it green when the route is selected. And so that's where that sort of like the higher level logic is involved. I can trigger the lights green, I can trigger them red, but my problem is that if I select the route so that it goes, the lights, let me see if I select this route here. See, so now what happens is it's green. So that's this track here. There's no locomotive, just cars, but they don't have any resistor settings on them, so the current sensing doesn't pick it up. But the route is selected, so that's why that LED is green. But then if I occupy the track, you see it goes to red, meaning there's a train in there. But then if the train leaves, see, the light goes out as opposed to going back to green to say, hey, that route is still selected. So now it's as if the route is not selected. So that could lead to accidents. And I know that that logic part is in the MGP boards. They have that functionality built in there, but the drawback is that it doesn't control as many LEDs as this board does. So that's where I'm going to have to play around with and update some, see how things progress. Then eventually what I'm going to do is I'm going to make a dedicated printed circuit board where I can just, you know, pop these LEDs in and the switches, and, you know, not have to do this prototyping where I'm bending over the pins and such. So that's how that progress is. But I'm really happy that I'm able to have the same LEDs go green or red or I can change it to yellow or blue. So maybe that logic I can end up having a JMRI, control that logic of the colors under what situation, that higher level logic, JMRI. But the thing is, I try not to. I would rather have dedicated hardware doing what I wanted to do and not rely on the software. In case the computer, in my case JMRI, I'm running on the Raspberry Pi, so it's a little bit I don't know, not secure, but reliable. But sometimes you end up corrupting the micro SD card gets corrupted, and you run into issues. So I prefer like a hardware system where just turn it on and everything works. So that's the progress. Thanks for listening. Bye.